Right, guys, in the previous lesson, we looked at the graph of sine x, which looks like a snake or S, the little cup graph, which is cos, and the tan graph with the asymptotes. Okay, so if we summarize this before we move to the next section, have a look here. Okay, the sine graph looks like an S. Okay, and remember it goes from 1 to -1, and you go 0 to 90, 180, 270, 360. The cos graph looks like a cup, okay, and the tan graph, it actually has an asymptote at 90, and then at 45 and 1 it does this, so it goes up there, then it comes down at 135, going down like that. Okay, and these are the points. That's basically the graph. In fact, if you go to -90 here, there's an asymptote here, and the graph at -45 goes there. Okay, so that's the tan graph, the sine, and the cos graph, and we're gonna keep referring back to that. Right, folks, what we're gonna now, we've looked at the sine, cos, and tan basic graphs. We're now going to go into amplitude shifts. And remember, what is the amplitude? If you get to the highest point on the graph and the lowest point on the graph, the highest y value, lowest y value, and you work out that distance, whatever it is, like with a sine, it was 2, and then you halve it, you get the amplitude. Now, what's very interesting, have a look at these graphs. If you take the first one, 2 sine x, okay, now there's a restriction from -90 to 360. How do we draw that? Very simply. Okay, have a look here. What I'm going to do is I'm going to use my pen, and I'm going to write down 2 sine x. Now, watch what happens if you use a calculator. Put in 0 there. The sine, 2 sine 0 is 0, so that's cool. But if you go 90 degrees, what is the 2 sine of 90? This is 1, and your answer is 1 times 2, which gives you a y value of 2. So at 90, it goes up there. At 180, it's there. At 270, it's there. At 360, it's there. So what's actually happening with 2 sine, the graph goes up, it stretches up. Look at this. And goes to that place, and up we go. Now notice, the highest value is 2 and the lowest value is -2. So that distance from there to there is clearly 4. Okay, so what is a half of 4? Is actually 2. And what is 2 is your amplitude. Look at that, the number here next to sine is your amplitude. And it's always positive because it's half the distance between there. Okay, but notice, if you look at the sine graph, this is very interesting. Have a look here. The sine graph was actually there. Okay, so the basic sine graph went like this. Isn't that interesting? It seems, therefore, that if you think about it, what's actually happened is that the red graph has stretched up to 2. The amplitude, it almost goes up, that 2 is almost the highest value there, you see, of the graph. And the amplitude is the half the distance. So it's an amplitude. It kind of stretches. It stays at 0, 180, and 360, but stretches. Very interesting. Okay, now let's look at another one, if you have a look here. What about 3 sine? What do you think? 3 sine, let's check. If we did this, 3 sine, well, okay, here we go. Well, let's see. If we take the graph of y equals 3 sine x, okay, what do we know? Well, let's test some values for it here. Okay, if we take 0, if we make 0 there, okay, that goes 0, so that stays. The 180 stays, and so does the 360. But now, if you go to 90, if we put 90 degrees there, the sine of 90 is 1 times 3 is 3, so it shoots up to 3. Then it goes down here. If you take 3 sine 270 and you work that out in your calculator, you get -3. So that comes down to here, to -3. Then it goes up there. So now what's happening is your graph does this. The amplitude is 3. Okay, notice what's the highest value? Is 3. The lowest value is -3, so the distance is 6. What's half the distance? Is 3. That's your amplitude. Look at this again. The 3 is the amplitude, the graph. And the basic sine curve was here. That's where sine was. And what's happened is it's gone and lifted up. Now, you can continue this down. You can actually go like this because they wanted -90 to 360. But that's 3 sine. What a wonderful graph. So it's sine, 2 sine, 3 sines. It's a stretch. Okay, very interesting. Okay, let's have a look at another one. What about negative sine? This is interesting. negative sign. Okay, if we look at this graph, negative sign and from 0 to 360, so let's see. Well, let's try it out and see what we get here. Okay, so if I've got y is equal to negative sine x, well, if we try x is 0, what is the minus sign of 0 is 0. And then what about minus sine of 90? Now watch that, that goes to negative 1. Now look what's happening here, then it does this. This is going down, it's reflecting. Okay, and then it's going to shoot up to there. Now that's the graph of this chap, negative 1. Okay, but notice something interesting. What is the amplitude? Okay, the amplitude is half the distance between the biggest parts, which is 1, and there. So this gives you an 2, so half of 2 is 1. So your amplitude is 1. It's the positive version, but this is going underneath. Okay, it's reflecting. Stay with us. We're going to come back and pursue this further, guys. Don't go away. It's important.